but they can see the difference between 3 and 2. It's something that's innate. It's born within us. This sushi bar, what you just went through, it shows that we're capable of recognizing up to 5 randomized objects without counting. As soon as you go beyond that, it becomes very difficult, and you saw that as you were trying to recognize 8 or 7 objects without trying to count. A lot of research then has now branched off of this, thinking about approximate number sense. Johns Hopkins University is doing research on how to whether our math ability is enhanced by our ability to approximate which one is bigger when comparing two quantities. But we've taken a different path here, and we've organized our objects. And all we need to do in this case is get from 0 to 9. You don't need to really see any objects with a greater quantity. And we call this subquanting, and relate it to our interfaces, because our interfaces only do 0 through 9. So as we deal with digits, we stick along that line too. So go ahead, Cooper, if you want to take them into shapes.
Okay. So I'm going to take you to the base A sheet, and what you're looking at here is just a placemat that says base A, and I can put a number on that placemat, and everybody should be able to see five little cubes. Why don't you type a yes just to let me know that you're res, because once you res on this, then it goes a little quicker. I see Marcus see it. Okay, Rosalind. Just the other 7. I'm just waiting for those quick Y's so I move on. Quicker I get them, the quicker we move. So we're looking to see if you see 5 green little squares. And so this is similar.
Screen wider if you are having difficulty seeing it.
Just, yeah, if everybody can see this, they'll be able to see everything. Okay, we're good. Okay. Now, we're looking at 5 little squares, but we could have as easily looked at 5 segs. It's just short for line segment. So we could have looked at 5 segs. Or I could have looked at 5 squares. Or I could have looked at 5 cubes. And the numbers here that we're looking at are all numbers we're familiar with. This is 5,000. In fact, if I put 1 in each place, and so we can see all of them. There is 5,000, which is a 5 in the cubes, 5 times 10 cubed. There's 1 square, so that's 100. There's 1 seg, so that's 10, and 1 left over. So you should be able to see this. And I just want to, we're going to stay in base A just for a second. I want to see if you guys can chat in. I know Rosalind can do this. I just want to see how quickly you can see a number. Okay, so I'm going to put in a number here and chat it in as soon as you can tell me what number you're looking at. Here we go. I'm sending them out. Tell me what number. Type that into chat.
Do one as an example.
Okay, we'll even let, oh, there we go. Lampu got it.
There we go, cool, Lampu.
Ah, there you go, 2314. Can you see it? Do you see the 2 cubes, the 3 squares, the 1 seg, and the 4 ones? Oh, this doesn't sound real profound. I mean, this is traditional decimal, so I'm doing place value, but we've discovered something interesting. If we'll do one more, just because I think you're all having fun. That's my opinion. I'll try to make it a little harder. Go, ready? Type it in as soon as you think you know what that number is. Lampu's on it, must have the fastest computer in the lab. Okay, John and Cass, I don't know if you typed wrong or you're looking at something slightly different. So you should see the 6 cubes, the 1 square, the 7 ones, and the 2 left over. Okay, probably when you came in, you didn't realize that you're looking at 6,172 little squares all at once. Now, let's move on to a different base, because Rosalind says we're getting it. And I want to show you that we have the ability to do this in in any base. There's the 6172 again, but we ran into a problem in our math research in that that's not 6,172 because they don't hold 6 containers. In fact, if I'll put on chat, and this is one of these tools that I have that's available to me, is that we can start interacting and show you some information of what's going on. There you see the 6172 in your chat. And the quantity is actually 4,520. So we designed a tool to help us look at this. And I'm going to take you to the tool right now. Here, let's just do a close-up of the tool. This is an actual prototype of a device that could be built in real life. You're looking at something we call the SQUID. It's the SQI3D. And it stands for a subquan controller. And everybody likes to push on buttons. So I'm going to just clear it. And by hitting the clear key, go ahead and push on it. Click on any button. Everybody can click on buttons. And you guys are having fun. Yeah. I'll turn the bass off. I'll take the bass off. Overflow. There, we changed to base 9. If you hold down the clear key, there you go. If you hold down the clear key, it cleared it all. And somebody did that. So yeah, now start playing again. And let me turn the chat back on, and you can see what you're...
If you roll your mouse over the controller, it'll clear. Without clicking on it or anything, you can just, it should.
Yeah, Malerica, yeah. Just there, good. Okay, so you can see this is a fully functional little device. It functions just like it does in real life. However, this device doesn't exist in real life. And we started the patent process, I have, to patent this and get this device out. So one of the big things about Second Life is it lets me create a device, test it, use it, before I even design it. And now what we're going to do is we're going to, if I can get everybody to stop playing with it, I am going to clear it. And I'm going to back out and look at 2 sheets and show you something interesting that we've observed. Okay, you should be able to see the base 8 and the base 9 sheet together. And I want to put in just one number. I'm going to send out, looks like maybe somebody, there we go. I'm going to send out, oh, I'm sorry, I'm on home base. My bad. Okay, there we go. Now, what I did is I sent the subquan, here, I'll put it on the, I'll use this one device that's in front of me. I used a different one. I'm going to go to base X. And that then talks to all the sheets. And I'm going to send out this subquan. There we go. Now you should be able to see one square in every one. And this is called a subquan meta pattern. It's 100. Let me put in 111 just so you can see the other, all of them. So there's the meta pattern 111, which in base 10 is 111. But in base 9, it's 19 squared, which is 81, plus 19, which makes 90.
Can you put the new data up, Cooper?
Oh yeah, let me turn on
because you have 100 up. The chat.
Okay, let me fix that. There we go. Sorry. I have the ability